So here are the essential conditions that to be followed for safe and proper operation of transformers. The first essential condition is primary windings of transformers must be suitable with supply voltage and frequency. And the second essential condition is transformer terminals of same polarity must be connected to same polarity bus bars. And the third important condition is transformers must have same X/R ratio. That is, we know that power factor angle phi is equal to tan inverse of X/R, which implies that here if transformers having different X/R ratio, then it will indicate that transformers will operate at different power factors. That is, if the transformers are operating at different power factors, which will lead to unequal load sharing by the transformers. Therefore, for proper parallel operation of transformers, the transformers must have same X/R ratio. And the fourth condition is transformers rating must be inversely proportional to their respective impedances. That is, S is inversely proportional to Z. Let us suppose transformer 1 is having a rating of SA and transformer B of rating SB. So SA by SB is equal to ZB by ZA. SA can be taken as equal to the terminal voltage into load current, and here the terminal voltages are same because these two are operating in parallel. So let's take that common voltage as V. Now let's rearrange this equation. So which implies IA into ZA by V, and which is equal to IB into ZB by, and if you multiply 100 on both sides, that will give you percentage impedance drop, and which is simply can be termed as percentage impedance. So which implies percentage impedance of ZA is equal to percentage impedance of ZB, or you can represent like ZA by V by IA. So V by IA is impedance, and this will represent the per unit impedance. So you can write per unit impedance of transformer A is equal to per unit impedance of transformer B. So the fourth condition can be termed as either the transformer rating must be inversely proportional to their impedances, or their percentage must be equal, or their per unit impedance must be equal. And the fifth important condition is transformers must have same turns ratio, which is also called as same transformation ratio constant K, which will indicate that the transformer induced EMFs must be same. If the transformer induced EMFs are not same, then in this circuit circulating current IC will flow, and because of which transformer will share the load unequally if circulating current flows. And of these conditions, first two conditions are very essential. If these two conditions are not met, then parallel operation of transformer will not happen. Whereas even these three conditions are not met, parallel operation is still possible, but there will be unequal load sharing. That is, there will be inappropriate load sharing. That is, if suppose transformer 1 is having 10, and let us suppose transformer 2 is having 20, and let the load be 30. So if all these conditions are satisfied, then this transformer has to share one part, and this transformer has to share two parts. This is proportionate sharing. If suppose of these 3, 4 and 5th conditions, any condition is not satisfied, then there will be inappropriate load sharing. Let us suppose this transformer is sharing 1. This transformer might share less than 2. Let us suppose 1.5 part. So which is inappropriate load sharing, and here this transformer is supplying less than what it is expected to supply. Then what happens? The burden on this transformer will get increased and this transformer will get overheated. Therefore, for proper parallel operation of transformers, these conditions are to be satisfied.